Hello students, welcome back to the second part of alternating current. So we did solve numericals up to 31, right? Oh, so next topic is LC oscillations. Let's have some break here. I'll start with the transformers. I'll answer these two questions at the end. Okay, let's start with the transformer. Okay, question number 34, right? Okay, so a transformer having efficiency of 90% is working on 200 volt and 3 kilowatt power supply. If the current in the secondary coil is 6 amperes, voltage across the secondary coil and current in the primary coil respectively are. So they are asking voltage across the secondary coil and current in the primary coil. Okay, so let's answer this. Observe the given data. So they gave input voltage, right? So transformer having 90% efficiency. So efficiency is 90%. So formula for efficiency is output power divided by input power. This is the formula for efficiency. Now, so 200 volt input voltage and 3 kilowatt power supply. So input power is equal to V input and I input. So I can write on it as V primary voltage and I primary current. So what is the value of primary current from this then? IP is equal to input power is 3 kilowatt, that is 3000 divided by input voltage 200, which is equal to 15 amperes. So this is primary current. Now what about secondary voltage? I have to find out secondary voltage, right? Now but you can use efficiency formula. So efficiency is output power divided by input power, where efficiency is 0.9. Instead I can write down it is as 90 by 100, which is equal to output is V secondary I secondary divided by V primary and I primary. So V primary into I primary is nothing but 3000, right? That is input power. Input power into 90 by 100, which is equal to, let me substitute this. So efficiency is equal to, sorry, not efficiency, let me substitute that value. So 90 divided by 100 is equal to, so secondary voltage into, what's the value of I as a secondary current? 6 amperes divided by 3000. So the 100 will get cancelled out. 2700, which is equal to Vs into 6. So approximately Vs is equal to 450 volts. Which option matches here? 450 volts and 15 amperes. Option B is the correct answer. Got it? This is one way of answering. So I have another way. So that is, we know the relation between voltage and current here in transformer. That is, so Vs by Vp is equal to Ip by Is, right? Hope you know the relation. Then from this I need Vs. Vs is equal to Ip by Is into Vp. So what is the primary voltage? Ip is primary current. So what's the value of primary current? 15. So 15 divided by secondary current 6. 6 divided into primary voltage 200 volt. We are going to get 500. So this method is wrong. There is something mistake. Oh, okay. So here it is. So its efficiency is 90%, right? So this formula is not suitable here. So this is when efficiency is 100%, you can use this method. As efficiency is 90%, you cannot use this. That means you can write on it is into 0.9. So this method is applicable into efficiency. We have to write it into efficiency because it is not ideal transformers, right? So into efficiency is 0.9. We are going to get 450 volts as an answer, this is the correct approach. Okay, so let's move on to the next one. The primary of a transformer is connected to DC battery of 10 volts draws a current of 1 milliampere. The number of turns of primary and the secondary windings are 50 and 100 respectively. The voltage in secondary and the current drawn by the circuit in the secondary are respectively. Super. Question number 35. So they didn't mention of any efficiency, that means it is an ideal transformer. So we can use this relation, that is V2 by V1 is equal to N2 by N1 is equal to I1 by I2, where 1 refers primary, 2 refers secondary. So that's what we have to use it right now. And one more thing, we have to cross check whether the transformer is not going to work or not. See, transformer works only for AC, it is not going to work for DC. What kind of supply they have given? They have given a DC supply. Will transformer work? No, it does not. So transformer works for AC only, not for DC. Not for DC. So 35. So for the question number 35, which option? So option C is the suitable answer because it is not going to work here. Okay, next. A 220 volt input is applied to a transformer. The output circuit draws a current of 2 amperes at 440 volts. If the efficiency of the transformer is 80%, the current drawn by the primary windings of the transformer. Okay. 36. Formula for efficiency. Efficiency is equal to output power divided by input power. So efficiency, how much it is? 0.8, which is equal to output power is nothing but I2 into V2. Input power is I1 into V1. Input voltage is given. What should I have to find out? Primary current. So which is equal to I2 is 2 into 440 divided by I1 I have to find out into V1 is 220. So 221s are 222s are. So 2 to 4, 4 2s are. So the I1 is equal to 1 by 0.2, which is equal to 5 ampere. Option D is the correct answer for question number 36. Next, 37. Let's try. So the primary and the secondary coils of transformer have 50 turns and 1500 turns respectively. If the magnetic flux linked with the primary coil is given by phi is equal to phi naught plus 4t, where phi naught is in Webers, t is in seconds, and phi naught is a constant, the output voltage across the secondary coil is. So formula for voltage, general formula for voltage is, this is a node point, V is equal to N into d phi by dt. So that's a general formula for voltage. Okay, just observe here. So how can I find out voltage? So first of all, find out voltage of primary. So primary voltage is equal to d phi by dt. You can use that formula. So d phi by dt, if you differentiate phi with respect to time, we are going to get 4. So 4 volts is the primary voltage. Okay. How can I find out secondary voltage? So V2 by V1 is equal to N2 by N1. We can use this method. N2 is 1500, N1 is 50, which is equal to 30. Then V2 is equal to 30 times of V1, where V1 is 4 volts. Okay, so answer is 120 volt. So next, a transformer is used to light a 100 watt 110 volt lamp from a 220 volts supply. If the main current is 0.5 ampere, efficiency of the transformer approximately is. Okay, so 38. So transformer used to light, they are given P2. So P2 is equal to 100 watt, and they have given V1 and V2. So let's find out P1. P1 is equal to, so P1 is V1 into I1, where V1 is 220 volts, I1 is 0.5 amperes, which is equal to 0.5 is nothing but you are going to get 110 watt. So this is input power. So output power is 100 watt, right? Then efficiency is output power by input power, isn't it? Which option matches? So 100 by 110 is approximately 90%. Option B is the correct answer. Got it? Next. The core of transformer is laminated to reduce eddy current losses. Okay. So to reduce eddy current losses, we are going to use a core which is laminated. The meaning of eddy current loss, eddy current is currents which are circulating on the surface of the core are called as eddy currents. Next question number 40. So a step-up transformer operates on a 230 volt line and supplies a load of 2 amperes. The ratio of primary and secondary windings are 1:25. The current in the primary. Okay, super. Formula for current and number of turns relation. So I1 by I2 is equal to N2 by N1. Okay, then I1 is equal to N2 by N1 is 25 by 1 into I2 value is a load current which is 2 ampere. Answer is 50 ampere. Option B is the correct answer for question number 40. Next question number 41. The primary winding of transformer has 500 turns, whereas the secondary has 5000 turns. The primary connected to AC supply of 20 volts and 50 hertz. The secondary will have an output of so V2 by V1 is equal to N2 by N1, where N2 is 5000 divided by N1 is 500, which is equal to 10. Then V2 is equal to 10 times of V1. 10 into V1 is 20, which is equal to 200 volt. 200 volt. So will transformer changes frequency? No, it is going to be same. What is the initial frequency? 50 hertz. It remains the same. So 200 volts and 50 hertz is the right answer. Frequency of transformer does not change while it is stepping up and stepping down. Okay. So next, so numericals are based on a DC source. So before solving these numericals, I would like to give a note point. That note point is a shortcut. The shortcut is disco. So meaning of disco is D represent DC supply. For a DC supply, inductor, I represents inductor, S represents, acts as a short circuit. Short circuit. Whereas C is a capacitor and it acts as a open circuit. Okay, hope you understand. So for a DC supply, inductor acts as a short circuit and capacitor acts as a open circuit. And this thing is applicable at t is equal to infinity. That means a steady state case. Steady state condition. How can I decide whether it is a steady state or initial stage? If switch is present, then there are two different cases you are going to get. If switch is not present, only one case, that is steady state case. So if t is equal to 0, okay, then it is going to be exactly opposite. For a DC supply, inductor acts as open circuit, capacitor acts as short circuit. exactly opposite. This is for transient state, steady state and transient state. Transient state. Meaning of steady state is t is equal to infinity. Meaning of transient state is so from t is equal to 0 to some other timing. Okay, so now let's observe this question. Question number 42. What is the question they're asking? Just try to understand this. Let's solve here itself. So figure shows a circuit that contains three identical resistors with resistance R 9 ohms each, two identical inductors with inductance 2 millihenries, and an ideal battery with EMF E is equal to 18 volt. The current I through the battery just after the switch is closed. This is important. So what is the meaning of discourse? In steady state and transient state, currents are different. So they are asking just after switch is closed. If just after switch is closed, in the sense at t is equal to 0. So at t is equal to 0, how circuit will behave like? So at t is equal to 0, circuit inductor behaves like open circuit, capacitor will behave like a short circuit. Let me replace it. Question they're asking current, right? So this is how circuit looks like. So you just remove all the inductors because it is open circuited, right? So and elements which are connected in series with the open circuit also eliminated. So now I am going to left with the circuit. So this is the circuit I am left with. Okay, so this is E and this is R. EMF is 18 volts. Then I is equal to V by R equivalent. V is 18, R equivalent is R by 2, where R is 9 ohm, so 9 by 2. So answer is going to be 4 ampere. Sorry. Yes, it is correct. 4 amperes is correct. So there is no any option. Actually, one of the option must be given as 4 ampere. Options given wrongly. Okay. Next question number 43. Hope you understood. Let's try the another one. A coil of 40 Henry inductance is connected in series with the resistance of 8 ohm and a combination is joined to the terminals of 2 volts battery. The time constant of the circuit is, so question number 43 is based on time constant. So we have a formula for a time constant, that is tau is equal to L by R for RL circuit, and tau is equal to RC for RC circuit, resistor and capacitor combination. Here they have given RL circuit, right? Then what is going to be time constant? Time constant is equal to L by R, where L is 40, R is 8, which is equal to 5 seconds is the correct answer. Which option? Option A is the suitable answer. Next, question number 44. 44 is based on switch numerical. So get ready. So as it is switch present, it's a there are two different cases possible. One is transient and steady state. We have to decide in which case they are asking the answer. So in the circuit given in the figure, 1 and 2 are ammeters. Okay, just after K is pressed to complete the circuit, the reading will be okay. Just after closing the switch, inductor acts as at t is equal to 0. Inductor acts as a open circuit. Come on, inductor acts as a open circuit. Capacitor acts as a short circuit. So let's replace the circuit. This is how capacitor acts as a short circuit, right? This is how circuit is going to be. And the inductor acts as a open circuit. So 1 and 2 both are ammeters. Okay. Now inductor is removed. This is 2. And the switch is K closed at t is equal to 0. This is the supply voltage. Is there any current flows through ammeter 2? No. So in 1 maximum current. So in 1 maximum because it is closed, and in 2 it is connected in series with the open circuit, that's why it is going to be 0. So which option? Maximum in 1 0 into option D is the suitable answer. Okay va? Next question number 45. Hope you are able to understand. So when the key K is pressed at a time t is equal to 0, then which of the following statement about the current I, the resistor AB of the given circuit? Okay. See, at t is equal to 0, as I told earlier, so capacitor acts as open circuit or short circuit? Capacitor acts as a short circuit. Then what happens? So t is equal to infinity. Okay, first of all, let me answer for this. At t is equal to 0, capacitor is short circuit. Circuit looks like this. So as capacitor is replaced with a short circuit. So you can eliminate this resistor because it is in parallel with the short circuit. So 2 volt and 1000 ohms. Now current in the circuit I is equal to 2 milliampere. Okay, so if t is equal to infinity, then what happens? Capacitor acts as a open circuit, right? If capacitor is like a open circuit, then you must consider another resistor. Okay, so these terminals, so this is open. If it is open, you have to consider on one more resistor. So this is 1000 ohm and this is also 1000 ohm and 2 volts. Again current flows through the circuit, then but I is equal to, here you are going to get 2 by 2000 ohm, that is 1 milliampere. So one thing you can decide, as time is increasing, current is changing from 2 milliampere to 1 milliampere. Which option matches? Option B is the suitable answer. For 46, the time constant of RC circuit is RC. So direct answer. Okay, so let's move on to the next question. Let's solve question number 47. An inductor of inductance L of capacitance C and resistor of R are connected in series to an AC source of potential difference V volt as shown in the figure. Okay, so potential difference is shown and they are already given what is the total current flowing through the circuit also. What we have to find out is what is the impedance of the circuit. Okay, super. So we know that total voltage Vs is equal to, Vs is nothing but RMS voltage here, square root of Vr square plus VL minus Vc or Vc minus VL. Here whose effect is greater, inductance or capacitance? Inductance. Voltage across inductor is greater than voltage across capacitor. That's why total circuit behaves like inductive circuit. So it's going to be VL minus Vc whole square. So which is equal to Vr square is 40 square plus VL minus Vc is 30 square, which results as 50 volt. They gave RMS value of current. I need impedance. Impedance is equal to Vrms divided by Irms. Vrms is 50. Irms is 10 by root 2, which is equal to 5 root 2. So that's the answer. Option B is the suitable answer. Understood? This is 2021 NEET question. Next, 48. A series RLC circuit containing 5 Henry inductor, 80 microfarad capacitor and 40 ohm resistor is connected to 230 volts variable frequency AC source. The angular frequencies of source at which power transferred to the circuit is half the power at resonant angular frequency are likely to be. Okay. So first of all, let's find out resonant frequency. Formula for resonant frequency, resonant angular frequency we are calculating. So which is equal to 1 by root LC, right? What's the value of L? 1 by root of L is 5 into C is 80 into 10 power minus 6. So which is approximately, so 10 power minus 6. Okay, so root of 400 into 10 power minus 6 will be there. 10 power minus 6 goes to 10 power minus 6. If it comes out, it will become 10 power 3 minus 3. If it goes to numerator, it's going to be 10 power 3, nothing but 10,000 divided by 20. So 0, 0 will get cancelled. You are going to get 50 radian per second. So this is resonant frequency, omega r, resonant frequency. And half power frequency, angular frequencies are omega is equal to omega r plus or minus delta omega, where delta omega is change in frequency. Formula for change in frequency is r by 2l. This is the formula of change in frequency. Then omega is equal to omega r plus delta omega once, and omega is equal to, can use omega is equal to delta r minus delta omega, omega r plus delta omega, omega r minus delta omega. These are the two possible frequencies here. So first of all, let's find out what is r by 2l, where r is 40 ohm divided by L is 5. So 2 into 5, 10. This will get cancelled. You are going to get 4. So omega is equal to 50 plus or minus 4. So one is 54. Another one is 46. Option C is the correct answer. Okay. Next question is based on transformer 49. A step-down transformer connected to an AC mains supply of 220 volts, that is V1 is equal to 220 volts, is made to operate at 11 volt, V2 is equal to 11 volt, and P2 is equal to 44 watts. Ignoring power losses, it means an ideal transformer. What is the current in the primary circuit? So formula for current in primary circuit, first of all we have to find out I2, right? So P2 is equal to V2 into I2. P2 is 44, V2 is 11 into I2. Then I2 is equal to 4 ampere. Then relation between voltage and current of transformer is I1 by I2 is equal to V2 by V1, where V2 is 11, V1 is 220, I1 is equal to 11 by 220 into 4. So it is going to be 44 divided by 22 into 10. 22 to, so answer is 0.2 ampere. Option A is the correct answer. Got it? Super. Next, question number 50. So question number 50, 2022 Neet question. Okay, so the peak value of AC source is equal to, it's a direct formula. So question number 50 solution. So Vm is equal to root 2 Vs, right? That's what they're asking. Root 2 times of the RMS source voltage. Question number 50. Option C is correct answer. Next, question number 51. So a series RLC circuit with inductance of 10 Henry, capacitance 10 microfarad, resistance 50 ohm is connected to AC source voltage. If the resonant frequency of the RLC circuit is F0, the frequency of the source is F. Then we have to find out relation between resonant frequency and the source frequency. First of all, let's find out the source frequency. Source frequency they have given it is as omega is equal to 200. Then F is equal to omega by 2 pi, which is equal to 100 by pi. Right? This is the source frequency, which is equal to V. Correct? Is it V or VF? It's not 100 by pi, it's 50 by pi, because 200 by 2 pi is there, no? Sorry. So I did mention here only. So it's not 200, it is 100 only. 100 by 2 pi, it is going to be 50 by pi. So this is equal to which frequency? Frequency of the AC source, that is V. Okay. Next, which option matches here? Frequency of the source V is equal to 50 by pi. So option 2 is matching. Okay, let's try for resonant frequency also. What's resonant frequency? So resonant frequency is V naught is equal to nu naught is equal to 1 by 2 pi root of LC. 1 by 2 pi root L value is 10 Henry and it is 10 into 10 power minus 6, which is equal to 10 power minus 4, comes outside 10 power minus 2, goes to numerator, it's going to be 100 by 2 pi, again 50 by pi. So resonant frequency and source frequency both are same. Option 2 is the correct answer. Next, let's solve question 2023 Neet questions. 52 answer. So an AC source is connected to a capacitor. So due to decrease in its operating frequency, what happens? So displacement current is produced due to varying electric field in between the capacitor plates. Nothing but so displacement current is the same as capacitor current, which can be replaced as V by XC. So where V by XC is 1 by omega C, then you are going to get omega into C into V. So displacement current is directly proportional to frequency. So as operating frequency decreases, definitely displacement current is also decreases. Okay, next question number 53. In LCR circuit, the inductance L is 10 millihenries, capacitance 1 microfarad, resistance 100 ohm. The frequency at which resonance occurs. Formula for resonance frequency, F is equal to 1 by 2 pi root LC. So let me substitute 1 by 2 pi root of L value is 10 millihenry, 10 power minus 3. C value is 1 microfarad, 1 into 10 power minus 6. 10 power minus 3, 10 power minus 6 is 10 power minus 9 into 10, 10 power minus 8. If it comes outside, it will be 10 power minus 4. Goes to numerator, 10 power 4 divided by 2 pi. So answer is approximately 1.59 kilohertz. Okay, so substitute pi value 3.14, then you will get the answer. Question number 54. So source supply frequency is given. Okay, the net impedance of the circuit they are asking. So formula for net impedance, Z is equal to root of R square plus XL minus XC or XC minus XL. It depends upon the value of XL. First of all, let's find out R value. R value is 10 ohms. XL is omega into L. Omega is 2 pi F. F is 50 hertz. 2 pi into 50 into, first of all let me substitute in formula, 2 pi F L, so which is equal to 2 pi into 50 into L is 50 by pi into 10 power minus 3. Pi will get cancelled out. 50 into 2 is 100, 100 into 1 more 10 here, 10 power 3, 10 power 3, 10 power minus 3 will get cancelled out. XL is going to be 5. Okay, this is 5 ohm. Next, XC is 1 by omega C, and 1 by omega value is 2 pi F into C. 1 by 2 pi F value is 50 hertz and C value is 10 power 3 divided by pi into 10 power minus 6. Pi will get cancelled out. So 100 into it is going to be 10 power 5. 10 power 5 into 10 power minus 6, 10 power minus 1 goes to numerator, it will become 10. XC is equal to 10. So definitely it is a capacitive circuit because capacitive reactance is greater than inductive reactance. So final answer is going to be XC minus XL whole square because it is a capacitive circuit. Then Z is equal to root of X. R is how much it is? 10 ohm, right? R is 10 ohm, 10 square plus XC is 10 minus 5. whole square. So it's going to be 10 square is 100 plus 5 square 25. So final answer root of 125. Root of 125 can be replaced as 25 into 5. So final answer is 5 root 5 is the correct answer. Option 2 is the suitable answer. So hope you understood all the numericals based on alternating current chapter. As I said earlier, after completion of all these numericals, come back to LC oscillations. Okay. So LC oscillations occurs when inductor and capacitor are connected together. So energy stored in both inductor and capacitor just exchanges. Those oscillations are called as LC oscillations. Okay, let me read it out. A condenser of capacity C is charged to a potential difference V1. Okay, super. So let's say 32 solution. Let me write it down. It is as Q1 charge flowing through it. So voltage across this is V1. Capacitor C, charge flows through it is, let's say, Q1. Formula for Q1 is C times of V1. This is the charge flowing through it. Okay, now the plates of condenser are then connected to ideal inductor of inductance L. Okay, now this capacitor plates are connected to ideal inductor. So whatever the energy stored in capacitor is delivered to inductor. Okay, and the current through the inductor when the potential difference, let's say potential difference is V naught. At this time we have to find out what is the current flowing through the inductor. Okay, first of all let's find out what is the charge flowing through it. Formula for charge flowing through it, let's say Q2 is equal to what it is, it's going to be C times of V2. This is the general formula. Whenever inductor and capacitor are connected, so you can write down oscillating charge formula as Q2 is equal to Q1 is the initial charge into sine omega t. Okay, so how to find out current then? I is equal to dq2 by dt, right? So let's differentiate. What is the differentiation of sine omega t? Sine omega t differentiation is cos omega t, right? So it's going to be q1 omega cos omega t, right? Cos omega t in terms of sine, it can be replaced as I is equal to q1 into omega 1 minus sine square omega t whole power 1 by 2. From sine square omega t plus cos square omega t is equal to 1. From that you can write down cos omega t as it is. Okay, now so we have to find out sine square omega t, right? Okay, just observe this equation. Let's say this is 1. So from 1, so Q2 is C times of V2, Q1 is C times of V1, then sine omega t. So C will get cancelled. Then sine omega t is equal to V2 by V1, right? Okay, sine omega t is known. So let's substitute. I is equal to, what is Q1? Q1 is CV1, CV1. What about omega? Omega is resonant frequency, right? Because we are connecting inductor and capacitor. So omega is 1 by root LC. Hope you are following. So it's going to be 1 by root LC into 1 minus sine square omega t is V2 minus V1 whole square whole power 1 by 2. Okay, so from this I need final answer as, let me substitute these things. So I can write down, so this one can be written as C times of V1 root whole square, or you can write down it as, so C square V1 square root divided by root LC into V1 square minus V2 square divided by V1 square whole power 1 by 2. Send these also inside it can be replaced as c square v1 square into v1 square minus v2 square divided by lc into v1 square. So whole power 1 by 2. v1 square, c and c will get cancelled. So final answer c into v1 square minus v2 square divided by l whole power 1 by 2. So which option matches? Option D is the suitable answer. Okay. Let's solve question number 32 also. Sorry, 33. A transistor oscillator using a resonant circuit with an inductor L of negligible resistance and capacitor C in series produces oscillations of frequency F. If L is doubled and C is changed to 4C, the frequency will be. So oscillating frequency is a resonant frequency, that is F is equal to 1 by 2 pi root LC. Then frequency F2 by F1 is equal to root of L1 by L2 into C1 by C2 square root of, so L1 is L itself, then L is double, that means 2 times of L, capacitance C, C2 is 4 times of C, so L gets cancelled, C gets cancelled, then F2 is equal to 1 by root 8 times of F1, where F1 is F, then F2 is equal to F by 2 root 2 times. Option for this question is option D. Okay, hope you understand. So with this chapter is closed. Thank you for your patience. Have a great day.